In this video, we're going to be talking about how do we find particular solutions of differential equations. So if you haven't watched the previous video first, in this playlist where you learn how to find general solutions. Basically, when we are finding particular solutions to differential equations, we need to use an initial condition to help us determine the value of C. An initial condition is a point that the solution passes through. Just as with finding general solutions, we have to remember the most important part is to separate the variables. All right, so let's start off with a question that's relatively simple in terms of finding the general solution, and then we'll talk about, okay, how do we find the particular solution? So to recap, when we find a general solution, we have to separate the variables. So by cross multiplying with this question, I have the x's on one side and the y's on the other. Then we integrate both sides. This is going to give me y squared over 2 equals x squared over 2 plus c. And then we try and get y by itself. That will give us the general solution. So I'm going to multiply everything by 2. Okay. We don't multiply c by 2. If we did, we would have 2c, which is not necessarily incorrect, but I'm just going to write c as some unknown constant in its simplest form. C is an unknown constant. 2c would be an unknown constant. So it's just simpler to work with c, so I'm going to be using that in this video. All right, and then we would take the square root. So we would square root both sides, put plus or minus x squared plus c. Once we have the general solution, so this would be our general solution, we need to now use the initial condition or the given point. In this case, it was a 0, 9 in order to find a particular solution. So first of all, I know that the particular solution is going to have a positive radical. That's because I have a positive value for y here. So if this said -9, I know that I need a negative out front. So what I'm going to do is, since it's a positive output, I'm going to rewrite this, and I know that that's a positive here. So I'm going to remove the plus or minus essentially. Then I'm going to plug in the point in order to determine the value of c. So I have 9 equals radical c. When I square both sides, I get that c is 81. So putting that all together, the particular solution is where we take our general solution, and I'm going to use the positive version here, change c to our now known value, and I get y equals x squared plus 81 as our particular solution. Okay. Now, we can check these problems. I'm not going to check all of them in the video, but I'll show this first one as a demo. So if I wanted to check, basically I'm going to take my equation and find the derivative of it. So I'm going to, on the left, get dy dx. Over on the right, recall that this is really x squared plus 81 to the 1/2 power. So I would have to use chain rule here. Bring the 1/2 down, subtract 1 from the exponent, but then multiply by the derivative of the inside. We can see over here, these 2's are going to go away. And if I rewrite this, I have x over the square root of x squared plus 81. So now I have this differential equation. I want to check if it's right. Well, if you notice here, the denominator is what we found over here to be equivalent to y. So if I have the square root of x squared plus 81 in the denominator, I could substitute y for that. And then if I zoom out a bit, you can see that is our original differential equation, so this checks out. So sometimes we have a little bit of algebraic manipulation to do within the check in order to make sure it matches the given differential equation. So again, I'm not going to check the others in the video, but just so that we know, we can check by taking the derivative of our answer. All right, let's look at number 2. I'm going to multiply both sides by dx or cross multiply, however you want to think about it. But when I do that, that does not separate the variables. So I'm going to either divide by y or multiply by 1 over y. And then I'm going to integrate on both sides. So over on the left, I have ln of absolute value of y. On the right, x squared over 2 plus c. Right? In the previous video, we talked about how we need to get y by itself. So we're going to basically treat those initial pieces that I have in pink there as the exponents. So e to that power on each side. That will allow us to get y by itself. And over here, this could be rewritten as using our exponential rules, c times e to the x squared over 2. Now that I have our general solution, I can plug in our point. So our point is 0, 4 in this problem. So this is going to give me e to the 0 power, and anything to the 0 power is 1. So now I know that c is 4. So if I put this all together, basically plug in c to our general equation, I have y equals 4 e to the x squared over 2 as our particular solution. All right, number 3. If dy dx equals y over x and y of 1 equals 2, let's find the particular solution. All right, when I cross multiply here, I realize that the x's and the y's are on the wrong side. So I'm going to do a little bit of manipulation by dividing by y on both sides while also dividing by x on both sides. You could do that in 2 separate steps if you prefer. And then we are able to integrate because our variables are now separated. So over here, I'm going to have ln of absolute value of y equals ln of absolute value of x plus c. Then we're going to use our log rules to simplify and get y by itself like we did in the previous problem. So I'm going to get y equals c, absolute value of x. When I plug in my point, so my point in this problem is 1, 2. You're going to see that we get 2 equals c. So let's put that all together, and our equation is y equals 2, absolute value of x for our particular solution. Number 4, if dy over dx equals sin of x over y and y of pi over 2 equals 2, we're going to, again, find the particular solution to the differential equation. So our directions are really all the same on these. It's just the differential equation is changing and that given point. All right, when I cross multiply, I will have separated the variables. That is our biggest step in these questions. Again, if you're in AP Calc, on the free response questions, sometimes they will give you 0 out of however many points if you forget to separate the variables. So they are deeming that the most important step and won't even grade anything after that, basically. So I'm going to integrate both sides. I get y squared over 2 equals negative cosine of x plus c. I'm going to solve for y in order to get the general solution. And I'm going to take the square root of both sides. All right, so similar to on the previous page, question 1, we're going to choose the positive version here. That's because our output over here at 2 is positive. And so this is our general solution where we're now working towards the particular solution. I'm going to, in this case, now plug in our point. So we have pi over 2, comma 2. All right, so a little simplifying to do inside the radical here. Cosine of pi over 2 is 0. So I have 2 equals the square root of c, which means c must be 4. And then we're going to put that all together. I'm going to basically take this piece here, and I have y equals the square root of negative 2 cosine x plus 4. All right, one last question on particular solutions. In this problem, we have if y prime equals 1 over x plus 3. So if you remember back from when we've learned implicit differentiation, that is the same thing as writing dy dx. So if you prefer the dy dx format, which I do, you can simply rewrite that. And now I'm going to cross multiply. So I have x plus 3 times dy equals dx. My variables are not separated, so I'm going to divide both sides by x plus 3 or multiply by the reciprocal, however you would like to think about that. And now I am able to integrate. So let's recall there's like a little imaginary 1 in there. So when I integrate, I just get y. Over here, I'm going to get ln of x plus 3 plus c. All right, finally, let's plug our point in. So we have 0, 1. So I have 1 equals ln of 3. I know I have a positive in here, so I can drop those absolute value bars equals, plus c. Now I'm going to get c by itself, so I'm going to subtract ln of 3 over. So we have kind of a funny expression for the value of c, but it is fine. It is still equivalent to some number. And now we're going to put this all together. So I'm going to take my general solution, change out the value of c, and this will be our particular solution for number 5.